Good morning to you all. Already we know that the poles, any one of the pole is on the right hand side of the S-plane, then the system is said to be unstable. We know. Already we have seen for first order, second order, up to third order we have seen. We know how to find the poles of first order, second order, up to third order. But beyond that, it's very difficult to find the roots of denominator, that is poles of the system. That's why it's difficult to say the location of poles. So there is a procedure to find the location of poles, whether it is on the right hand side or left hand side or on the j omega axis. For that, there is a criterion called Routh-Hurwitz criterion. Let us see that. Next. Test the stability of the system whose characteristic equation is S cube plus 5s square plus 6s plus 30 equal to 0. Now let us form the Routh array. S cube, S square, mod and all 1, 5, 6, 30. Now S power 1 we have to form. 5 multiplied by 6, 30, A, B, C. Therefore, C1 equal to 30 minus 30 divided by 5 equal to 0. 0. So we cannot proceed further. But this is, we have to replace by epsilon, or what we have to do? For that, we have to see the previous example. S power 1, how many elements are there? Only one element. Here, S power 1, how many elements? Only one element. Therefore, even though it is only one element, this is called row of zeros. Row of zeros. Even though it is one element, first column element is 0. So rule is we have to replace by epsilon. But if it is S power 1 means we have to consider it as a row of zeros. In that case, we have to form S power 1, we have to consider S square row. We have to consider S square row. That is auxiliary equation. That is called auxiliary equation. 5s square plus 30 equal to 0. So we have to differentiate this dAE by ds. We find that 10s plus 0, that is 10s. Therefore, S power 1 equal to 10. S power 1 equal to 10. That's all. S power 0 is what? S power 1 is 10. Therefore, 10 multiplied by 30 minus 5 multiplied by 0. Therefore, you will get 30 here again. 30 here. So, if we check the set of all first column elements, that is S cube, S square, S power 1, S power 0. What are the elements? 1, 5, 10, 30. No sign changes. No sign changes. Shall I tell stable system? No, we cannot say. Now itself. No sign changes. So here, we have to consider the auxiliary equation. Auxiliary equation. Roots of auxiliary equation are roots of original equation. Original equation. What is the original equation? S cube plus 5s square plus 6s plus 30. Therefore, auxiliary equation roots are roots of original equation. What is the roots of this auxiliary equation? 5s square plus 30 equal to 0, or s square equal to 30 by 5, that is equal to minus 6. Therefore, s equal to plus or minus j root 6. The roots on the j omega axis. We know that if any of the poles on the j omega axis, it is marginally stable. Marginally stable. So therefore, the given system is not stable. It is marginally stable. It is marginally stable. So even though there is no sign changes, if auxiliary equation is there, we have to consider the auxiliary equation. The roots of auxiliary equation, any of the roots of the auxiliary equation is on the j omega axis, then it is not stable. It is marginally stable. Here, the roots of auxiliary equation is plus or minus j root 6. Therefore, it is marginally stable. Let us check what are the location of poles. Let us check in MATLAB. Now let us check by using MATLAB. MATLAB, we have to find the roots. The function call is roots. We have to pass the parameters, that is coefficients, that is 1, 5, 6, 30. Two poles on the j omega axis, 2.4, 2.4, two poles on the j omega axis. Real part is 0, only imaginary part. That's why it is on the j omega axis. What we found in Routh array is correct. Two poles on the j omega axis. Therefore, it is marginally stable. Marginally stable.